Want to look at one of my favorite sections of our entire series, and it deals with this idea called a quadratic equation. And I know we've talked a little bit about this before, so let's just recap what we've already known and what we know. We know a quadratic equation has a basic form of a ax squared plus a bx plus a c equals 0, such that in this case a does not equal 0. What happens if a did equal 0? Well, then we would just have a linear equation, some bx plus c equals 0. So it's this x squared that makes it a quadratic type of a function, or type of an equation. And we've seen some of these in the past before. We've seen, imagine a 2x squared plus 7x minus a 4 equals a 0. And we've learned how to kind of solve those. And we learned that some of these, the ones we've done in the past so far, well, we can solve them by factoring. And we look to see how does it factor down. This equals a plus 4 equals a minus 1. For this to be true, either 2x minus 1 has to equal 0, or x plus 4 has to equal 0. And then we solve for what x are those true. And it looks like it's true for x equals 1/2 or x equals -4. So we found out that this quadratic has two solutions, and that those two solutions represent points on a graph. And we'll explore a little bit more about this later, but maybe to give you a little bit of a teaser, this tells me that I have a solution at x equals 1/2. So it's 1, 2, 3, 2, 3, 4. So there's 1 at 1/2 here. Let's do it this way. 1 at 1/2, 1 at 4, and that we're going to discover, yeah, it's supposed to go right through there, that it has a bowl type shape of a look. We'll discover a little bit later too that the bowl holds water. It's not an inverted quadratic in this particular case. And so that's kind of some of the things we've discovered so far. And we can also attach a function notation to this as well, because this is a function. The quadratic does fulfill all the properties of being a function. And so we can also rewrite them in function form or function notation. Again, such that a does not equal 0. And we can live with that type of an idea. So what we're going to do though is I think we're going to come across some quadratics here pretty soon that maybe we can't solve by simply factoring. And in that case, what do we do? So what I'm going to do is I'm going to introduce to you this idea. It's called the square root property.